In the previous video, we introduced the ideas of classes and objects. In this video, let's look at their syntax more specifically. We're going to do this in the context of modern Python, which uses type annotations for better, strong typing guarantees so that we can be more confident in the correctness of the programs that we write. When we define a class, we use the keyword class followed by the class name. So here's the class keyword, just like def. This is a reserved word in Python. You can't use the word class for anything else when it comes to identifiers. And then we give an identifier, which is the class name. For the purposes of this template that we're looking at, I want to point out that these square brackets are not characters that you would write when defining a class. We're saying this is where you would put the class name. This is sort of the placeholder for where you would introduce the class name. When it comes to the class name, we should note that the conventions that are common in the Python programming language are different from how we think about our variable names or our attribute names. When we define classes in Python, we're going to begin their identifiers with a capital letter, and we're not going to use underscores between words. We're going to use capital letters to denote when the next new word of a multi-word class name begins. This is called camel casing because if we were to outline this and put humps over the capitalized letters, we would have humps that appear to give the outline of a camel. And this is different from our snake casing of our attribute names, which are also used, the same convention is used when we're declaring variable names, right? So with snake casing, we use all lowercase letters and separate words that make up a multi-word identifier with underscores. So we define our class by giving it a name. And then just as is in common in Python, when we define when we're making some statement in our syntax, in our programs, we'll give a colon and then we will indent to indicate that whatever comes next is in the body of this class and belongs to this class. So what we're about to say are we're going to declare our identifiers, our attributes, and the attribute names are identifiers. Each attribute is defined in a way that feels very much like a variable because we think of these attributes as grouped variables that are declared inside of a class, where we give a name, which is an identifier that you get to decide, and the type that is associated with that attribute for the class. You'll notice that on the second example here, we are able to provide some default values for our attributes, and we'll look at an example of this in just a moment. And when we think about what does it mean for us to define an attribute, we can think about this as the statement, an object of type class name will have an attribute of type name whose type or whose data type is whatever we've defined. So this is easier to read in a concrete example. A Twitter profile object will have a follower's attribute of type integer, right? So let's take a look at a more specific concrete example because sometimes looking at this and a syntactical template doesn't necessarily make it easier to understand. Let's break down what we're seeing in this example. So here we're defining a class named Twitter profile. So Twitter profile is the class name. Notice it is in camel casing. Right? So here's our capital T and then P is the beginning of the next word. And we've used that convention to name this particular class. Each of the attributes is then indented one level and looks just like a variable declaration where we give the name of the attribute followed by its type separated by a colon. And in the case of followers and is private, these are attributes that have default values associated with them. Right? So after defining this class, we know that any object whose type is Twitter profile is going to have these three attributes associated with it. Once we've defined this type, we can actually use it as if it were a type anywhere else in our program once it's been introduced. So we could have a variable, and that variable's name might be a profile. And we could say that its type is Twitter profile, right? And so we can't use this variable yet, but we can declare a variable whose type is Twitter profile. We still need to initialize it. And this is where things get a little bit different with classes and objects than we're used to with some of the built-in types. So let's look at how we can initialize our class variables or our object variables whose types are classes through the use of a constructor function. When we need to initialize a composite data type value, we need to construct a new object. And by convention, the name of the class of the type of object you're trying to construct is going to be the name of the constructor as well. And this is a function. So we can use the name of the class to refer to the class. But if we put the parentheses after it, like a function call, it will invoke that class's constructor, which sets up a new object that we can then interact with. And we're going to get a reference to this back. We'll take a look at this, what this means in terms of the memory implications in just a moment. But notice we're saying a profile is a variable whose type is Twitter profile. That's the class we just defined. And in order to initialize this variable such that we can start using it and start accessing its attributes or assigning to its attributes, we need to construct a new Twitter profile object before we can use it. And this differs from how we interact with our literals, right? And our default, or I should say our built-in types. So when we have an integer, we can use integer literals. We can just write a number and initialize an integer variable to a number, like x is assigned 0. We don't have to construct a number. You've actually interacted with constructors before, though, when we've converted types from one another, right? So when you said stir of 5, stir is the constructor for the string type, and that constructor is established such that it can take an integer or a float and convert that value into a string representation. Similarly, we can take use the int constructor to construct an int value and give a value such as, say, the string 5. And we've used that before to convert between a string that had characters which represented a number to an actual number we could perform arithmetic on. So you've seen constructors before, but those were built in and you never saw their definitions, and we had literals available to us in order to initialize our values in a more direct fashion. Well, because we are defining these classes as custom data types, there isn't a literal syntax available to us that would need to be built into the programming language ahead of time. The constructor is a special function, and its purpose is to initialize an object or all the attributes of an object so that it's ready to be used. We're going to look at today the use of the default Python constructor, and in a future lesson, we will look at how we can write our own constructor to ensure that if there are certain properties that we know that we're always going to want to change as soon as a new object is set up. For example, when you register on Twitter, you always want to register with a custom unique handle. And when we construct a Twitter profile object, we should probably have to give a handle as a part of its construction. But we're going to look at that later. For now, we're going to assume that when we construct a new profile or construct a new object more generally, we're going to use the default constructor that's built into every class in Python. As a minor disclaimer that's noted at the bottom of the slide, we don't have to use any special syntax in Python to construct a new object. In other languages, and if you continue on and use other languages, you'll often find that you have to write the keyword new before constructing a new object, and there's more ceremony involved in constructing new objects. With Python, we just give the name of the class and call it as if it's a function, and that will construct a new object for us. So what's actually happening behind the scenes when we construct objects in Python? Well, imagine that we have the following, the line of code at the top of this slide, where a profile is being assigned the result of evaluating the function call Twitter profile. And that is a call to the Twitter profile constructor. So when that expression is evaluated, what's going to happen in the heap area of our stack of our memory, not in the stack. So we would imagine this code is running within a frame on the stack. When the heap, some space would be allocated to store each of the attributes that make up an object. And those attributes will initially be bound to whatever default values we set up with the class's attribute values. If there were a custom constructor defined, which we will look at in a few lessons, that would have been called. But for now, we're going to assume that there's just some behind the scenes, magical, automatically available to us function, which is carrying out the task of establishing this grouping of attributes in our heap, right? So if we were trying to diagram this, we would diagram a box whose type is Twitter profile and has these attributes associated with it. When this expression returns, right? So when this expression evaluates, the return value is actually a reference to this Twitter profile object. So if we were thinking about how we would represent this in a memory diagram, we would have a variable a profile, and after that line of code evaluated, it would refer to the object that was constructed on the heap. And remember, all of our variable names are going to be bound in frames on our stack. All right. When we read an attribute, we are saying a profile. So the way to read this expression here, a profile.handle, is initially from left to right, right? So a profile is going to be a variable that refers to this particular object. And then the dot operator that we're seeing is saying, hey, look inside that object. So follow this reference arrow and look inside this object for an attribute named handle and give me back whatever it's bound to. And in this case, it would be the string Chris Jordan, right? When you use the form object followed by a dot and then an attribute name, you're saying, hey, object, what is the value bound to this specific attribute? So this is how we're able to read an object's attributes and use those attributes at various points in other expressions in our programs. If we want to assign or overwrite an attribute, we can use the assignment operator. And notice that on the left-hand side of the assignment operator, we are directing where we want this assignment to happen. So this left-hand side value is a profile.handle. So we're saying we want whatever is on the right-hand side of this assignment operator to overwrite the previous value that was stored or bound to this particular attribute in our object. So here, a profile.handle is assigned the string UNC, is what would cause that particular attribute to be updated. The general form, and I shouldn't have a semicolon here, you should ignore that, is object.property is assigned whatever value we want. You'll notice that I'm using the word property here, and I'll come back to this in just a moment. The terminology that programming languages tend to use is language specific. So in Python, we use the word attribute to describe a bundled variable that's a part of an object, right? And when we define our attributes in our class, we're defining, when we have an object, what are the attributes that will be associated with it. Well, Python's attributes have different names in different programming languages. In Java, you would call these instance variables. In C++, you would call these data members. In JavaScript, properties. They all mean effectively the same thing, but the underlying semantics can be a little bit different language to language. In the way that we're describing the concept of attributes in this lesson and the way we'll think of them in this course is very broadly applicable to these other languages and in how you generally think about them conceptually. If you go on deeper and become a professional Python programmer, you'll learn that there's more nuance to how some of these things work, such as how default values work, than what we're letting on to here. But the model that we're giving you for how to think about the attributes of a class and what that implies about each of the objects that is constructed from that class are how you should generally think about these concepts and apply in each of these languages. Just know that each does have its own specific rules. You'll also see the concept of an object referred to as the concept of an instance in other languages, but these are also just two words for the same thing. So this was a quick introduction to the syntax of working with objects made up of attributes. And later we'll learn how do we add our own constructors to our classes and thus all of our objects, as well as methods so that we can add some additional capabilities built into every object of some type. But for now, our focus is how do we actually just use classes to bundle a group of variables such that all of our objects contain those variables and we can model more complex concepts with them. In the next video, we're going to look at how do we practice this and apply this knowledge in a real program that models a pizza ordering application.